Hello guys, I'm going to talk about right triangle similarity, which is, obviously we've talked about lots of similarity, but specifically I want to talk about something called the altitude, which a triangle has three different altitudes. Altitude is really just a fancy word for what we think of as being height. Okay, the key of course to height, which I continually mention, is that it's a segment that's perpendicular to a side. Okay, so obviously I could call like this the height and this the base of a right triangle, but if I draw the height from the vertex where the right angle is, if I do this and draw the altitude here, a very interesting thing happens. And so let me clean this up and show you a better example. Alright, so let's say I have this right triangle ABC and I have drawn the altitude AD, so AD is what we would call an altitude. Okay. And what I hope you notice here is that when I draw the altitude of a right triangle, I actually have three similar triangles drawn here. Okay, because we know that X and Y have to add up to 90 degrees because all three have to add to 180. Well, if I look, for instance, at triangle ADC here, if this angle up here is 90 and this is Y, then what does this angle have to be? Well, it has to be X because they have to add to 90. And if I look at this triangle BDA, the small one, again, this is a right angle right here, which means X and this angle have to add to 90, which means this angle is Y degrees. So by angle-angle similarity, we have three similar triangles, and let's write a similarity statement about that. Okay, I cleaned that up a little bit for us. But so what we've got here is if I have triangle ABC, okay, where A is the right angle and B is angle X degrees and C is angle Y degrees, that would be similar. And let's talk first. Let's talk first about the small triangle here and think about what angles correspond with each other. Well, the right angle is here by vertex D. I'm going to turn this to red. Is angle D. Angle B is the X. Okay, this was the short side of our original triangle, and X degrees is still represented by the B. Okay, and I don't know where that stuff just popped up from, but and then A is my Y degrees, which corresponds with vertex C in my original triangle. And next, let's look at this other triangle here, ADC. And we can see, I hope, now I still have angle D is where my right angle is, but my X degrees is down here where point A is, and my Y degrees is at point C. Okay, so I have these three different similar triangles. You notice that, for instance, like DA in this triangle DAC is the short leg, and DB corresponds with that in this triangle, and AB corresponds with that in this triangle. They're all the short legs, and you can check that with the next thing, right? Like AC is the long leg in the original triangle, DA is the long leg here, and DC is the long leg in this triangle. So I hope you see that these three triangles are similar, and we can make some statements. Obviously I could write a lot of different statements, but maybe if I wanted to say something like AB over AC in the large triangle, that would be short leg over long leg, has to be equal to, in my next triangle over here, the smaller one, it would be short leg is BD over AD, right? And we can see that that matches up with our similarity statement, right, where AB and AC is equal to BD over AD. We can see that matching up. And then in this triangle, the short leg is AD and the long leg is DC. And we could write lots of other things like that. But let's look at a specific example or two with this going on. Alright, so in this case here, we've got this right triangle ABC, and I've got some lengths. Keep in mind that we also still know Pythagorean theorem, so we can always use that to find things out as well. But let's take a look at this large triangle, which is what I know two values of, 15 and 25. I know that, for instance, 15 over 25, which is the ratio of the short leg to the hypotenuse of triangle ABC, right? That's what these are representing. This has to be equal to the short leg which is what I have right here, compared to the hypotenuse of this small triangle ACD. So I'm looking at triangle ACD right here, and the short leg is my x that I'm looking for, and my hypotenuse is now 15. And so now I can solve this by multiplying by 15 on both sides, for instance, and x is equal to 15 times 15 is 225 over 25, which gives me 9. Okay, so I know this is 9. And we could find y in a variety of ways at this time. Maybe the easiest is just to do Pythagorean theorem, so something like 9 squared plus y squared equals 15 squared. And so that would give me 81. Hopefully you're seeing that this is a perfect Pythagorean triple, right? So this is this is like a multiple of 3, and this is a multiple of 5, which means this has to be a multiple of 4. Right, so if I multiply 4 times 3, it would make sense that y is 12. I hope you see that. We could finish Pythagorean theorem if you wanted. I could also use a proportion to find z or something like that. Right, I could say if this is 12 and this is 9, I could do something like 9 over 12 has to be equal to 15 over z. Or again, I could use Pythagorean theorem to say 15 squared plus z squared equals 25 squared. Notice again, if this is a 3, 4, 5, then so is this, because they're all similar, right? So if this is 3 times 5 and this is 5 times 5, then z obviously is going to be 4 times 5 and z is 20. But obviously we can do this with Pythagorean theorem, with proportions, with Pythagorean triples. There's lots of ways to attack it. Alright, this problem is very similar, or is using a similar idea. Here we have x. If I compare this triangle, x is one leg, it looks like the short leg, and 16 is the long leg. Whereas in this triangle over here, they switch roles. I want to do that in a different color, sorry. Right, and it's not just about short leg, long leg. We can do this with looking at the angle measures, right? So like for instance, if this were A degrees, this would be B degrees, which would mean in this triangle here, this would have to be A degrees, and in this one, this would have to be B degrees. You can kind of match things up that way. So x over 16 in this triangle on the top has to correspond to 9 over x. Okay, I don't know why this is not letting me write, but so what we have here, if I multiplying both sides by x and multiplying both sides by 16, I get x squared equals 16 times 9 is 144, and x equals 12.